Hello my friend, you are welcome to my channel. This video is the ongoing series of generative AI course. Okay, and as of now, we are learning about perceptron. So in this video, what we're going to learn about how to use perceptron model using Sklearn. As of now, we understand all the basic concept like what is perceptron, training, everything we understand. Okay, and now in today's video, we will just understand it is so simple. It is so simple to use this model. You don't have to do a lot of maths. Everything is rewritten. Everything is already pre-written by the Sklearn module. Okay, so let us understand in this class that how to use Sklearn Perceptron module to solve our problem, and we can use the perceptron model. Okay, so without much delay, let's get started and let's understand how to use Sklearn library to solve the problem using perceptron. Let's get started. In today's class, you're going to discover about perceptron model using Sklearn, right? Let me recap what we have covered as of now. As of now, if you have seen my previous lectures, then you have very fair understanding, good understanding about perceptron. So we started with the perceptron concept. What is the perceptron model? How it works? Mathematical intuition and graphical intuition. Geometrically, we try to understand what is perceptron, and we also cover like how the training happens, like how the perceptron does the training on the given data set. And after the training, we discover one important formula. It is called perceptron. If we have seen my previous video, it is called perceptron update rule, right? So this is very important formula or important rule which perceptron use to update its weight and bias, right? This is everything we have already discovered. So what is the rule? Let's suppose we have how the weights and bias gets updated, right? So the rule was that we had discovered. I'm not going in the detail in this video because I have already created a lot of videos about the detail. Okay, so the update rule says that the new weight, I'm saying w dash, is equal to old weight plus eta into y minus y predict into x. Okay, this is for weight. And for bias, new bias is equal to old bias plus eta into y minus y predict. Okay, so these are called the first equation, second equation. This is called update rule. Okay, update rule for, and how it works, what is the mathematical intuition behind that, what is the geometrical intuition behind that, everything I have covered in my previous video, which I'm not going to cover in this video. Okay, so one thing whatever topic, whatever I covered here, this update rule. Okay, so basically you don't have to, this all thing happens behind the scene. Okay, or I can behind the scene, or you can say it's an algorithm. Okay, whatever I discuss as of now, like perceptron update rule, so it's an algorithm, mathematical algorithm, that how perceptron uh, apply this algorithm to update its weight and bias. Okay, this all everything we cover. But when suppose when you are working in a project, okay, or suppose when you want to utilize or apply these concepts, you don't have to start from a scratch. What I'm trying to say that you don't have to start from scratch, or I can say that you don't have to write these update algorithms. Okay, update algorithm which I have covered. Okay, if you want to start from a scratch, I mean you want to write your own algorithm, or you want to write the code for the algorithm, which is not required. Okay, because it's kind of util, or it's kind of one time activity, or it's kind of logic. Okay, it's kind of logic. So basically when we work with the project, or when we work on the data set, you don't have to apply this logic, or you don't have to write this thing from the scratch. You have to apply the logic, but you don't need to write this logic or manually. Okay, so for that, whatever logic, whatever you have the understanding about perceptron, how the perceptron work, the update rule, forward propagation, backward propagation, I think you have all the concepts. Okay, so everything is already written. Everything, all the logic is already written for you. You don't have to write from a sketch. Everything is written for you. So for that, we use Sklearn. I hope you know what is Sklearn. So Sklearn is a ML library. Okay, it's a ML library which have a lot of algorithm, right? Like it has random forest, it has a random forest, it has a logistic regression, it has a linear regression, it has a lot of ML model, mathematical model which help us to solve our problem. Okay. Similarly, Sklearn has one more algorithm called perceptron. Perceptron. Okay. So as of now, whatever I have discussed in the class, this was like giving the introduction that how the perceptron work, what are the mathematical intuition, how the training happens, how the update happens. So I was trying to establish a concept around the perceptron. Okay, but this whole thing which I discussed in the previous video, you don't have to write from scratch. You don't have to do coding for that. So all the coding, okay, everything is written inside this module perceptron. Okay, like forward propagation I discussed, right? We have to create weights and we have to apply weight X, this everything, right? And then a backward propagation, right? Then we have to apply the rule update rule, and we have to update our weight and bias, right? So everything we have seen. So everything has been already, I mean, already coded or already written inside this model in the perceptron logic. You don't have to write anything from scratch, okay? But you should know the concepts, that how the forward propagation works, how the update works. You should know the behind this and how it works. So that was my purpose for previous videos, okay? So in this video, we will see that how to utilize this concept, how to utilize the Sklearn library, okay, of perceptron, and how to solve our problem. And it's right. And trust me, writing the logic, okay, I mean, writing the code is very simple. Writing the code with perceptron is very simple. You don't require much coding skill, okay? So let us understand how to utilize perceptron model and how to solve our business problem, okay? So for that, I will not take much of time. So already I have already uh, written some code, or I already have some solution for that. Okay, so I'm already using perceptron model. So for that, I will just demonstrate you this code, that how to get to use it, and it's very simple. Trust me, it's very simple. Okay, so let me start one by one. So here I'm. So here for the data creation, I'm just using MK Sklearn data set library. I'm just creating some random or creating some data set just to solve my problem. Okay. In the real project, you could have real data set, but here I'm just showing some data. So it does not matter if you know the machine learning steps. If you already have a machine learning background, you know how to do data cleaning, outlier detection, normalization, scaling, finding the duplicates, okay, finding the removal the outliers, removal the duplicates, how to scale the data. All the pre-processing steps is still required here. I'm not covering that. I'm assuming that you have already those pre-processing concepts. Okay. Let's suppose you have a data, then how to apply the model, how to apply the algorithm which is given by Sklearn. That's what my purpose. Okay. So here I'm using this make classification, and here first I'm getting two-dimensional array. Okay. I mean, I'm using this kind of data. So in case number one, I have two cases to show you. So case number one, I have 2D data. 2D data. Okay. So 2D data in sense, I mean, I have two features. Suppose this is my data, like in tabular format. So let's suppose I have given example like salary, okay, and city, and the purchase will happen or not happen. So this example I have already sent. So here I have two data. I have only two features, salary feature and city feature. So this kind of data is called 2D data. I mean, you have just two features. You are working with only two features. Generally, in the real case, it is more than two features, but let us start with the two features. Okay. So here you can see that I'm generating only two data set, only two features, okay, in my sample, and I'm creating 100 sample, I mean 100 number of rows, okay. So let me run this. It's a very simple code. And if you see this plotting, I'm just using a scatter just to show the data. It's very simple data. I have already seen you before also, okay. So here I have only two features, and these are the one features and the other features, which is the yellow one. Okay, and here we have to, as per the perceptron, I need to draw a straight line which will separate my two classes. This is the purpose of perceptron, right? So whatever we have studied so far, everything is coded, or everything has been encapsulated into this model perceptron. So how to utilize perceptron model? You have to use this library, Sklearn dot linear model import perceptron. Okay, so this perceptron comes under linear model. It is not, as you know that perceptron is just a straight line or just a plane. So it's a linear model. It is not a non-linear model. Okay, so here this is what you have to import from this import perceptron, and this perceptron class has all the concepts, like whatever is required, whatever concept you have as of now, everything is there. Okay, so now I'm creating this class. I'm creating the object of perceptron. Okay, and then if you have an ML background, then I think you know everything about this. So then I'm calling the fit method. Okay, so first you need x and y. What is my number of features and what is my label? So y is nothing but the label. Okay, let me show what is a y. So here, if I show you x, okay, what is x? So x has two features. Let me print x. Okay, so x has two columns. This is the first column, second column. Okay, and if I want to see the y, so y is nothing but the labels 101010, two classes. Okay, and then I'm just fitting into x and y. So it's very simple. You can see that the code wise, writing the code is pretty simple, very straightforward. Okay, and all the logic, everything is written inside the perceptron class. Okay, if you have the background, so just call the perceptron and create the object. Okay, this is your reference, and call fit method and pass your x feature and y feature. Okay, then what happens behind the scene if you're calling fit method? Okay, what happened basically, suppose you're calling p dot fit, right? You're calling p dot fit and passing x features and y label. Okay, so what happens behind the scene? So behind the scene, it does two things. The purpose of this fit is what? To find, the purpose is find the right boundary, right? Right boundary, it can be straight line, it can be a plane, it can be hyperplane. This is what the purpose of perceptron, right? So if I call fit, then what it will do, it will start the training. It will start the training. And how the training happens, if you have seen my previous video, then we do first we do forward propagation. Okay, I mean matrix calculation, x1 xw, this one plus b. This is called a forward propagation, and then it called backward propagation. I mean update rule. I mean change the weight. New weight is equal to weight w eta into y minus y dash into x, and bias b is equal to b plus eta y minus y dash. Okay, so actually fit, this function fit actually doing all this operation behind the scene. It is, maybe you're not able to see right now, but behind the scene they are doing all the operation which we have seen manually as of now in my previous video. You don't have to do any manual code setup. Everything is written inside the perceptron. You have to just call fit method, that's all. Okay, just, there are two steps. Just create the first you just import the perceptron. Second, create the object like p is equal to perceptron. Okay, perceptron, and call the fit method. That's all. Only three steps are required, and your perceptron training is done. It's very simple, right? But yeah, but just to understand that what the fit is doing, what is happening behind the scene, you have to build the concepts which we have already built it. Okay, so it's very simple. So I call fit, and now I hope you know that what is doing the fit. It is doing the trainings. Okay, and after the fit, the training happens. Okay, it will do all the trainings. It will find the weight and bias, and after training, okay, suppose after learning the model, it will give you two things. Okay, the fit after training, it will give you two things. Okay, first it will give the coefficient, and intercept. That is the purpose of my training, right? Coefficient means I want my W1 and W2. W1 and W2. Why W1, W2? Because I have two features. Because I'm working with 2D data, right? So for two-dimensional data, I have only two features, and I will have one intercept. Suppose intercept can be B. Okay. So this is what I want to know, that after the training, what is my new my W1 and W2, and what is my weight. Okay. So that's what you can get it after the fit call. So after the fit call, I'm calling p dot coefficient. Okay. So this p dot coefficient will give you what? These weights, W1, W2. Okay. And you can see that if I run this, let me import it. I'm calling fit method. And after the fit, so fit is actually taking the training. It is doing the training behind the scene. Okay. And then after the training, if the training is done, then it will give you weight and bias. And p dot coefficient, it is giving you all the weights. So I have two weights here because I am working with two features. So I have two weights. So this is W1, this is W2. And then it will give you intercept nothing but the bias. Okay, so this is what I wanted to know after the training, what is my weights and what is my bias, which I got it. Okay, so if you have a weight and bias, then you can predict new lines, or you can predict the whether for the new data set, okay, whether the purchase will happen or not happen. Okay, so that prediction you can do. And here I just want to graphically, I want to show the new line. Okay, you know that the purpose of fit, okay, is a discussed, right? Why we calling fit method? Just to find the right boundary. I need to find the right boundary. So the boundary can be a straight line if it is two-dimensional, or it can be plane or hyperplane. Okay, so here just to want to show you after the training what is the boundary I got it based on this weight and bias. So this is what I'm doing here. So I'm using this library like plot decision reason. This is very useful library to plot a single line. Okay, so here I'm calling it, and I'm just passing my input x and y, and I'm passing my model. P is my model, right? Perceptron. This is my model P, because now P has seen my data. So now P has all the detail about my data. They understand the relationship between the data. So this is my model. Okay, so I'm passing this. If I run this, it will plot a line. So this is the boundary. Okay, so after learning on this data set, on this x and y, my model P, which is the model perceptron, they find this is the straight line, which is best fit line, which is separating these two classes. Okay, and on basis of that, you can perform prediction. This is a very simple data set. Okay, now let me show you 3D data set, because here I have shown you only 2D dimension, 2D data set. Okay, let us see that in case of 3D data set, how the boundary will appear. Okay, so if you know the concept, so this is the concept, right? In 2D, if you have two features, then the boundary is a straight line. Okay, if we have a three features, 3D, then boundary will be plane, right? And if we have more than 3D, 4D, 5D, 6D, more than if you have more than 3D, then it will be hyperplane. The boundary will be hyperplane. This all thing we have already discussed. Okay, so now I have shown you 2D data. Let us understand, let us see the 3D data. I have a three features. Okay, I mean I have x1, x2 and x3. I have three features. Then what can be the boundary? Okay, so in case of 3D data, in case of three features, I will have three weights, right? W1 weights for x2, W2, and for for x3, W3. So in the 3D data, you will have three weights, W1 plus W2 and plus W3, and you will have one bias. Okay, this is the setup or for the 3D data. Okay, so let us see in the 3D. So it's very simple. Again, for 3D, I'm again creating some data point using the same class called make classification, and here and features I'm passing 3. Earlier I was using 2, now I'm using 3. Okay, and here I'm creating 1000 data sets. Very simple. Okay, and then yeah, so let me show this. It's very simple. Let us run this, and this is my data. I'm plotting this in the data. Okay, and after the plotting, you know that it's a 3D data, so it will be a three dimensional. Okay, so this is my first dimension, x, y, z, in the 3 dimension. So in the 3-dimension data is looking like this. So I have two classes. One class is for purchase and one class which purchase not happen. So 1010. Okay. So you can see that uh, these two lines, just assume that these 2 points are hanging in a cloud, hanging in the space. Okay. So here now my task is I want to find a plane so that I can separate these two classes. Okay. So that's the purpose of perceptron. So that's what I'm using perceptron. I'm again calling perceptron from the same library. And now I'm giving some different variable named P2. Okay. And I'm just same thing. I'm calling fit method. So fit will do everything as I discussed earlier. Fit will do training, everything. And I'm just running it. And after the fit, then it will give me what it will give me weights and bias, right? So here in this case, how many weights it will give you? It will give you 3 weights because I have 3 features. So for each features x1, x2, x3, it is giving you 3 corresponding weights, and it will give you 1 bias -2. Okay, now based on whatever weights and bias I got, okay, I got 3 weights and 1 bias. I want to draw the boundary, okay, based on whatever I got it after the training. Okay, I got this 3 after training. I want to plot a boundary. I want to plot a boundary so that I can visualize that how the separation is happening. Okay, uh, how the separation is happening, I want to visualize it. So for that, I have written very small function. This function will plot a plane because I know that I have 3D. So in 3D, it will be a plane. The boundary will be a plane. So here I want to I want to plot a boundary or plane so that I can see the separation. So it's very simple function. Okay. So I need to pass a model. So model is nothing but this my perceptron P2. This is my model, and I need to pass my inputs, my X features and Y labels. Okay, and uh, and based on that, internally, what it's doing from the model, it is finding the weights and bias, and accordingly, it is creating the plots. Okay, you can. I will share this file. You can download this file and you can understand this code. It's simple visualization technique. Okay, and if I let me run this code. Okay, and this is my function, and in order to call this function, you have to pass this parameters. Okay, so I'm passing my model, which is P2, and input is X, and label is Y. Let me plot this. Okay, so you can see that it was my this was my real data, orange one and blue one. Okay, and you can see that it is drawing as plane. This is the plane. Okay, so this way it is trying to separate these two classes. Okay, so similarly, guys, I want you do the next things because I have covered only 2D and 3D. Okay, you can expand it, you can extend it, or try to generate 4 data points. Here just instead of 3 features, you take 4 features, 5 features. Okay, and try to see whether you can just follow this same code perceptron model, and you can follow the same code. Okay, and try to see that what figures or what boundaries you get after the perceptron. Okay, so I wanted to show you this one that whatever you have learned so far, like training, forward propagation, backward propagation, update rule, everything you don't have to do manually. Everything is done by this class called perceptron. Okay, you have to just call the fit function. You have to pass the input, and it will do everything behind the scene. And finally, you will get your coefficient. I mean your weights and bias. Okay, and on the basis of weight and bias, you can find the prediction, or you can also plot that boundary, that what are the boundary you got from the model. So this is what I wanted to show in this class. It was very quick class. Okay, but it was important to show you that this how to use Sklearn Perceptron. Okay, so I hope now you got all the basic understanding about perceptron. So as of now, let me recap what we have covered. If you have seen my previous video, I have covered all the basic logic of perceptron. What is the perceptron? How it works? What is the mathematical intuition? What is the graphical intuition? How the training happened, which is very important to understand how the update rule works. What are the mathematics behind that? Graphically, how it works, And also today class I show you that behind the scene what are the library used by machine learning, which is a Sklearn. And you don't have to do all the mathematical step or any coding stuff. But yeah, you should have the basic understanding, the logic, the concept behind that. And you have to use perceptron class and just call fit method. Your work is done. Okay. And this way you can solve your business problem, whatever business problem you have. Okay. So yeah, so this is what in this class. In next class, I will talk about more about perceptron. There's a concept called error. Okay. So next class, I'm going to cover about the errors, loss function. Okay, what are the different loss functions, the concept of loss function or error function in perceptron. This I will cover in the next video. Okay, so stay tuned and watch my next lecture on loss function, which is used in perceptron. Okay, it will be very interesting one. Okay, so this is all in this video. I hope you got all the understanding of perceptron, how it works, and keep learning. I hope you're enjoying my lectures and you're learning something. Okay, so put in comment box, my friend, if you still have some doubt or you need some additional resources, you need something, please put in comment box. I will try my best to answer those questions and I will help you if you have still any doubt. Okay, so this is Raj. This is all in this video. I hope you got all understanding. I will come back in the next video where I will talk about loss function, which is very interesting. I will see you in the next video. Till then, goodbye.